So let's go over a few more examples. First one, we covered the 0 over 0 indeterminate form many times now. So let's go over this problem here. We're asked to find this limit. Limit of 1 over 1 minus x minus 2 over 1 minus x squared as x approaches 1. You'll notice here that the first term, this one, goes to either plus or minus infinity as you approach x, as x approaches 1 from either the left or right. And the same thing happens to the second expression here. So this yields an indeterminate form of this type. And the strategy here is to transform this into a fraction. Then we first identify, so we first do some algebra to write the denominator of the second expression in this way. And we have a common denominator. We can factor this out and write this as a fraction, so we can, that is 1 plus x minus 2 divided by 1 plus x. This is the same as the limit when x approaches 1 of 1 over 1 minus x. We compute 1 plus x minus 2, 1 plus x minus 2, divided 1 plus x. This is the same as the limit when x approaches 1, 1 over 1 minus x times x minus 1 over 1 plus x, which is the same as the limit as x approaches 1 of 1 over 1 minus x times, and x minus 1 is the same as minus 1 minus x. If you just flip the signs when you when you distribute the minus 1 inside, and so we may cancel the 1 minus x and 1 minus x, and we just get minus 1, the limit when x approaches 1 of minus 1 over 1 plus x. But now we can use the law of the quotient, because the numerator is a constant and the denominator is a polynomial of degree 1. It doesn't vanish when x is equal to 1. It just gives us minus 1 over 1 plus 1, which is 2. So the final answer is 1 over minus 1 over 2. Okay, so that's one more example, and the next example I wanted to go over with you. What's this limit? So the limit when x approaches pi over 4 of sine x minus cosine x over tan x minus 1. And why did I want to do that? Well, because this is example doesn't involve polynomials, but instead trigonometric functions. Again, all boils down to some algebraic manipulation. We're computing the limit of sine x minus cosine x over tan x minus 1, but tan x is the same as sine x over cosine x. When x is equal to pi over 4, sine of x and cosine of x are the same. They are both equal to square root of 2 over 2, or 1 over the square root of 2. And so tan is going to be equal to 1. So that makes both the numerator and the denominator vanish at the point. So we need to do something to get rid of that that problem. And so you can either factor by cosine, by cosine on the top, which is what we're going to do, or manipulate the bottom. So here I'm going to factor, take a common factor of cosine. So here to get sine, I need to divide by cosine of x. So when I bring the cosine inside, I just get sine. And the cosine here, the second term, just becomes cosine when I bring this inside. And now the bottom is sine of x over cosine cosine of x minus 1. But this is what I had from the, but this is the same I have on top. And remember that since x is not pi over 4, sine x over cosine x minus 1 is not equal to 0. So we can cancel this out, and we just get this is equal to the limit as x approaches pi over 4 of cosine of x. But now we are allowed to use substitution because cosine of x is equal, it is continuous everywhere. So we may just plug in pi over 4, and this is just square root 2 over 2. And this is our final answer.